Let's take a look at finding and graphing x-intercepts. These are the points where the quadratic equation would cross the x-axis. If it does cross the x-axis, every situation we're working with right now will cross the x-axis at some point or another. So going back to the concept of factoring that we've worked with, we have a couple versions of factoring here. The first one is just a plain old simple trinomial. There is no common factor in any of those terms, 1, 11, and 24, nor the x's. So we're just going to factor this using the simple trinomial method. So when we factor that, we have two brackets that I like to set up beforehand. And then because it's a simple trinomial, it's just going to be x out front. And I'm going to find two numbers that add to 11, multiply to 24, especially focused on the multiply to positive 24 first. Two numbers that multiply to 24 and also add to 11 are 8 and 3. If you don't see that right away, you can list pairs of numbers that multiply to 24 and then see which ones will work to get the addition in the middle term. But 8 and 3. So positive 8 times positive 3 is positive 24. Positive 8 plus positive 3 is positive 11. The order doesn't matter. You could write this as x plus 3 times x plus 8. You're going to get the same result as long as you have an 8 and a 3 there listed. In the next case, this is not looking like a simple trinomial because we have a 3 out front. However, first thing we look for is a common factor. And yes, there is a common factor here, a common factor of 3. All three of these terms are divisible by 3. 3 gets divided out. We're left with x plus 4x minus 12. So x squared plus 14 should not be 14, should be 4x. Getting a little exuberant here. There we are. Factored. All done, right? Wrong. We have not finished factoring this because x squared plus 4x minus 12 is also factorable. There are two numbers that will add to 4 and multiply to negative 12. Specifically, those two numbers happen to be positive 6 and negative 4. Again, if you need to make the list of numbers that multiply to 12 and then find out which ones will make it negative. Again, it's got to be plus and minus because 12 is negative. When you multiply two numbers together and they get a negative, one needs to be positive, one needs to be negative, and then figure out what pair will be a positive and subtract to get the 4. And that should not be 6 and 4. Again, getting over exuberant here. That should be a 2, 6 and negative 2. So that cleans that up. All right. Now, this one here, there is no common factor. 9x squared minus 24x plus 7. No common factor, so we need to factor this by the decomposition method. That way there, what we do is we first off multiply the first and last coefficients. 9 times 7 is going to give me a positive 63. So I need two numbers that are going to multiply to positive 63, but also add to negative 24. And what I will do is I will rewrite this middle term as the two terms that work. So two numbers that multiply to 63, but also add to negative 24. Negative 21 and negative 3. Again, order here doesn't matter. You could put the negative 3 first and the negative 21 second, as long as you have those two numbers in there. And what I'm doing is just breaking that negative 24x up into two terms that will add to it. Now, common factoring. I common factor the first pair. I get a 3x. And when I factor that out, we're left with 3x minus 7. Using the middle sign there, negative, the only common factor is 1. So I'm factoring out a negative 1, and I'm left with 3x minus 7 as well. That leaves that's a common factor of 3x minus 7. When I factor that out, remaining is 3x minus 1. So that there is factored now. And then the last one, it's a difference of squares. How do we check for a difference of squares? Well, we got to see if there's a difference between the two terms. There is. Minus means difference. X squared minus 1. That's its difference. And now, are they perfect squares? Yes, x squared is a perfect square. And surprising to many people, 1's a perfect square. 1 times 1 is 1, meaning that 1 is a perfect square. This is one of the tricky questions for people because they forget that 1 is 1 squared. Difference of squares, when we factor it, there's a plus in one bracket, a minus in the other bracket, and then we just square root each term in place. X squared, square root of that is x, and the square root of 1 is 1. That is that term factored. So there's some different types of factoring you might see moving through this section. Now, getting into some of the actual work with it, and some of this is a little bit of review because we've done this kind of concept before and brushed on it, but I just want to elaborate a little more on it. So sketching y equals 3x squared plus 12x minus 36 using the zeros. So we need to find the zeros of this. Just to cheat a little bit, make a little shorter of a video, we've already factored this. That's the factorization of it. So step 1, we factor that out. So this becomes y equals 3x plus 6, x minus 2. Now to find the zeros, and I've told you before, the easy way to look and see is just to say, okay, that's going to be negative 6 and positive 2. Why is it like that? What's going on? Well, at the 0, if we have our graph, the zeros happen when y is 0. So when this equation equals 0, we have our zeros, our roots, our x-intercepts. What would make this 0? Well, multiplying anything by 0 will make it 0. So either this is equal to 0, x plus 6 equals 0, or x minus 2 equals 0. If one of these two things is 0, the whole thing is 0. So let's solve this. Both of these, actually. X equals 0 minus 6, or just x equals negative 6. Or x equals 0 plus 2, or x equals 2. That is the mathematical representation of why those numbers become opposite of what's in the brackets. Because when we set it equal to 0, what makes this term equal to 0? What makes this term equal to 0? It's the opposite number. So that there gives us our two zeros. So we have a 0 here. 2, 4, 6. They say 6 is right here. Negative 6. And then our 2 will be right here. So there's our zeros. Need another good key value. Let's get the vertex. It's an easy one to find. How do you find the vertex? We've done this before. It's the middle of these two terms. In the symmetrical type of graph, it's in the middle. How do you find the middle of two numbers? Add them up, divide by 2. It's like the average. So the h value of the vertex is negative 6 plus 2 divided by 2. That's going to get us our h value. Negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. So our h value of the vertex is negative 2. So right here at negative 2, and then it's going to be opening upward. So down here somewhere, we're going to have our vertex. How do we find the y value? We take this value, sub it into the equation. Doesn't matter, this original or this. I'll go back to the original since we have it there. 3 times negative 2 squared plus 12 times negative 2 minus 36. Negative 2 squared is 4. 4 times 3 is going to give me 12. 12 times negative 2 is going to give me negative 24 and then a minus 36. Simplifying that down, 12 minus 24, negative 12. Negative 12 minus 36, negative 48. So our vertex And I guess I could even have changed that y to a k value. Let's even change it now. Let's change to a k value, because the k value of the vertex. There's our k value. So our vertex, which is at hk, is -2, -48. And thus, -2 way down. It's going to be actually down here. It can be stretched way out, but we're going to miss-scale this and make that -48 down here. So we won't have an equal scale on this graph, but something like this, except it would technically, if you had an equal scale, would be way down, 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 down on the graph here. So there is our rough sketch of our graph, and that's -2, -48 as our point there. It gives us 3 points of reference for our graph. Could also say that this point here is -36 because we know the y value from there. So we got 4 points on our graph. That gives us a lot of information about that graph that could be useful when solving different types of problems. So again, to determine the zeros, you're just setting each possible term with x, multiple with x equal to 0, and then solving that. And then to find the vertex, you are adding the zeros, dividing by 2 to get the h value, or the x value of the vertex, and then the k value, the y value of the vertex. We sub that into the equation to find that. If we're given zeros and a point to determine the equation of the parabola in standard form, very similar idea to what we just did. We take what we know. We have our y equals a x minus r, x minus t format. Again, r and t are the zeros. I use r and t. I believe the textbook uses an s instead of a t, but I think my s's look like 5s, and I don't want to confuse anybody. So now we have an x-intercept here. That could be our r. An x-intercept here. That could be our t. And then this could be an x and a y value. We can fill in this equation and find the a value. Y equals 5. A is what we're finding. X was a 1. 1 minus our r value, which is going to be +6 here. And then 1 minus +4, or 1 minus 4. Simplifying that, 5. And again, that is a 5, not a 6. I'm sure someone will see that. And even though I said 5, they'll think it's a 6 because of my poor writing skills. 1 plus 6 is going to give us 7. 1 minus 4 is going to give us -3. Simplify this. 7 times -3, -21a. How do you get that multiplication over to the other side? You're going to divide it. 5 divided by -21 is our a value. So there's our a value. Therefore, in standard form, which is y equals, or sorry, we can't get standard form yet. We got to expand this out. So y equals 5/21, that's negative, times x plus 6, x minus 4. We got to expand this out and get our value. So we actually have to go through the full multiplication. So I'm going to do this 5/21 last. We're going to get x squared minus 4x plus 6x minus 4, or minus 24 when we expand that out, rather. Simplify that inside. Plus 2x minus 24. And now we're going to multiply everything in the brackets by -5/21. So it's going to look a little messy. -5/21 x squared minus 10/21 x plus 5 times 24 is going to give us 120/21. Both those are divisible by 3. And so if we divide both of those by 3, we're going to get plus 40 over 7. And there we have the equation in standard form. It's a little messy, and I know a lot of people are uncomfortable with fractions. I'm not. I think fractions are awesome, and so should you. But that is the equation in standard form. In many of the cases in the textbook, I believe you'll get whole number values and not fraction values in most cases. So one more situation here to look at, just really quick. Going back to the previous, when we're finding zeros, if we have 9x squared plus 24 minus 24x plus 7, in this case here, if we want to find the zeros of that, we want to factor that. This would be a complex trinomial to factor. We already did it earlier in the examples of factoring. This factors out to 3x minus 7, 3x minus 1. Now, if we want to get the zeros, we set y equal to 0. 3x minus 7, 3x minus 1. So to make this whole thing equal to 0, either this equals 0 here or this equals 0 here. Okay, so one or the other is going to equal 0. They could both equal 0, but it's not going to happen at the same time. So let's solve these. So either 3x minus 7 equals 0 or 3x minus 1 equals 0. One of those two equals 0. In both cases, we'll get two separate answers. You can't just pick one answer, though, because it does cross at 2 points. But this situation will happen at both these situations, either this or this. So solving this, 3x equals 0 plus 7, or 7. X equals 7 over 3. The other situation, the other x, is that 3x equals positive 1, or x equals 1/3. That is the pair of zeros when x equals 7 over 3 or x equals 1/3. So if you have the situation where you have a complex trinomial and you have a number in front of the x, again, that is just is a matter of simplifying that equation when you set it equal to 0. Okay, so that is zeros, graphing, given the zeros, finding the vertex given the zeros, and a little review on factoring.